The permanently increasing number of electrical devices requires a control of the energy consumption. It is therefore necessary to find a solution enabling to save energy in new and existing installations. Today, 72% of the electrical consumption is used for electrical motors. 63% is used for the circulation of fluids. Only 5% of the pumps and fans are equipped with drives. For these applications, atv38 is a new concept providing comfort and energy saving. Our tests on 2 application demo models will clearly demonstrate this. The fan model enables to clearly demonstrate the energy saving as well as the advantages achieved in using atv38 drives compared to conventional airflow regulation systems. In the case of a conventional installation, the motor is directly supplied by the mains and the flow variation is achieved by means of outlet vanes. Starting the motor generates important current peaks, up to 7 times the nominal current, and important shocks on the mechanical parts. The electrical and thermal overloads reduce the number of possible start-stop operations. They consequently limit the lifetime of the motor. In addition, the motor can only be run at its nominal speed. The flow variation is mechanically obtained with outlet vanes, without reducing correspondingly the power absorbed. Whereas the flow decreases by 20%, the power itself is only reduced by 3%, as shown by the power flow graph recorded on the model. Using an atv38 drive, the starting current of the motor is reduced and the mechanical structure of the fan is protected. The thermal overload protection of the motor is permanently ensured by the drive. The flow variation is directly obtained with the variation of the motor speed. With the suppression of the vanes, important savings are achieved during installation and maintenance. With atv38, a 20% decrease in the flow rate results in 50% power reduction, instead of the 3% achieved with the conventional solution. With the energy-saving function of the atv38, you fully benefit from the télémécanique know-how. Concerning the high switching frequency, it makes atv38 a noiseless solution, ideally suitable for the building sector. For all your ventilation applications, atv38 provides comfort and energy saving. This is also the case for the pumping applications, as shown with the model where an atv38 simulates a water distribution system in a hotel. It guarantees pressure stability, irrespective of the flow rate, thanks namely to a built-in PI regulator. In the case of a conventional installation not using atv38, with 3 auxiliary pumps directly connected onto the electrical mains and a wide flow range, when the flow rate goes up, the pressure goes down. Let us take the example of the hotel. When all guests consume water, the ground floor guests have a satisfactory water pressure, whereas the last floor ones get only a very low pressure and consequently very little water. With atv38 and its pump switching board, full control is ensured. In this application, the 3 pumps play a different role. One pump has a variable speed and is directly connected to the atv38. The 2 other pumps have a fixed speed and are directly connected to the mains. For a given water consumption, atv38 starts the pump with variable speed. It is controlled by the regulator built in atv38, and the pressure feedback is given by the sensor. The same regulator adapts the pump speed to the water consumption in order to maintain constant pressure, and thus avoiding water hammers. If the consumption increases and exceeds the nominal pump speed, atv38 switches the auxiliary pumps with fixed speed. In case of consumption decrease, atv38 makes the auxiliary pump stop. With atv38, it is also possible to operate beyond the nominal motor speed. This limits the number of necessary starts, and as a consequence, the mechanical wear and the corresponding energy consumption. atv38 provides you with a perfect comfort and control of your pumping station in a very simple way, economically and safely. atv48 is designed to optimize the operation of your machines by reducing the voltage sags and the overcurrent during starting, by reducing the mechanical and hydraulic stress. Our atv48 soft start, soft stop unit is mainly used for pumping applications. Whereas the steady state operation is not a real problem, the transient state, start and stop, can generate devastating effects if uncontrolled. Water hammers that can lead to duct bursts. Depression effects. Overpressure generating an early wear of the ducts. Valve jerks generating noise and vibrations damaging the adjustment of the pipes. A didactic model enables us to highlight the hydraulic transients by visualizing the variations in flow and pressure. The water is pumped from a lower basin by a centrifugal pump. It circulates in a pipe whose length varies thanks to a system of valves and is discharged into an upper basin. The hydraulic phenomena during the transient phases can be displayed with a flow meter and pressure sensors. 3 types of starts and stops can be simulated: direct online, with a conventional soft starter with current limitation, with atv48 and its exclusive concept of torque control. Direct online starting generates a rapid acceleration of the fluid and a sudden pressure increase inside the duct. The uncontrolled deceleration provokes a sudden stop of the fluid, resulting in a water hammer and overpressure and depression effects in the duct. An increase of the duct length leads to an amplification of the phenomena. The water hammer level is higher, as well as the depressions and overpressures in the duct. Conventional soft starting with current limitation makes a start very difficult and consequently generates motor temperature rises. The high acceleration at the ramp end generates a sudden pressure increase in the hydraulic pipes. It is noted that deceleration doesn't take place immediately after the stopping order, and this because the torque is not controlled. Deceleration is rapid and uncontrolled. It can result in water hammers. The anti-water hammer tank is switched off for this third simulation. With atv48 and its torque control, a progressive acceleration is maintained up to the nominal speed. It thus avoids any negative effect on the duct and improves the life cycle of the mechanical part. On stop request, the atv48 torque control enables an immediate and soft deceleration from full speed to stop position. The water flow decreases progressively. There is no sudden variation of the pressure. As clearly shown with the test model, atv48 enables a very effective reduction of water hammers and valve jerks irrespective of the pump load state. The comparison between 3 stopping types highlights the perfect control of the torque during the pump deceleration. The result is a better management of the hydraulic transients.